Cool. So, hi. Thanks for stopping by. My name's Tim. I come from a company called Sensible Objects. You may be able to tell from my accent that I have travelled far to be here today. So I wanted to give a talk this year about something that we've had to find out the hard way, making the stuff that we make. Because I want to kind of share some of the lessons that we learned and some of the processes that we went through. Because it turns out it's really hard to make things physically, and it's really hard to find out how to make things physically. People kind of guard that information like they should hold on to it, because more often than not, they want you to pay them to do those services. So specifically, I wanted to talk about something that maybe some people here might be facing now, which is maybe you have a prototype that you've made. Maybe it's just bits of card and paper, maybe it's 3D printed. Maybe you have an idea for something, and the gap between where you are now and actually getting a thing made so it can come in a box and sit on a shelf just seems like a leap that is like a chasm you can never cross. It's totally possible to cross that chasm, you just have to know the steps. I usually give these talks with a projector because slides are really good because it means that people focus on this rather than me, but there aren't any. So this here, this wonderful piece of signage, is a link that will take you to some supporting images and videos that you might want to have a look at whilst we're talking. So feel free to open that up. It'll take you to a Google Doc. It's got maybe like 10 slides with some videos. So I'm fine if you want to sit and look at your phones. Also, it means you can like do other things and look like you're participating. So if anyone has any questions, please just ask them while we go. Very relaxed, very informal. So, a little bit about me. So I'm an industrial designer by trade, so that puts me at a little bit of advantage already, which is kind of cheating. But the stuff that I was taught was miles away from the kind of lessons I had to learn here. The company, Sensible Objects, we were 5 people. We started 4 years ago. None of us had done anything like this before. So we had a games coder, we had a designer, we had a business guy, an artist, and we all did the first version of Beast of Balance, which is our game here. We did it as a side project, so we did it on our own time alongside other things, because we wanted to see if we could take some of the things that we find interesting about games and technology and put them together into something that we could get manufactured. Who's heard of this before? Who knows a little bit about this? Any hands? Because I'll know how to... Great, no hands, that's brilliant, okay.
I mean, if you count the event registration where I researched you, sure, but that was like a week and a half ago.
You did research, so that's good. Okay, 1. Brilliant. So Beast of Balance is quite unique. So it's a physical game. I can't get it all out here, but it's a big box of plastic and electronics. And the way that it works, the best way to describe it is it's kind of like Jenga and Pokemon together. So it's a dexterity game, but... So yeah, we would all be working together to build a tower out of all of these little plastic pieces, a little shark. But inside this shark is a tiny piece of electronics. So when we play the game, when we put the shark on the tower, it wirelessly connects to a tablet, and that spawns a digital shark in a world that's connected. So this is quite a complex thing. The moral of the story is if I can make this, then you can make whatever you want to make, it's fine. So there's electronics, there's plastic, there's packaging, there's software, there's shipping, there's logistics, all the things that you would need to know, we've been through them and I'm going to talk through. So what I want to do, does anyone have a prototype that they're thinking of making, or is anyone interested in manufacture, or are you just here, interested in manufacture? Okay, so I'm going to tailor it based on this. It's okay. Some of it's going to be very specific to you, a couple of slides, the rest of it's very general. So, probably going to take about half an hour, not longer than that. Questions anytime you want. So, yeah, let's go back to the beginning. So, I'm going to be handing out some stuff while we talk. So, I want to show you where we started from so that you can see the progression. In fact, okay, the very first version of this plastic injection molded shark with electronic tag in it was this Duracell AA battery. I'm going to hand these out because I'm sure you've never seen one of those before. And this piece of wood with the word eat on it. And this other one with the word breathe in it. I'm not going to bother you. So the reason I'm showing you these is prototyping. Sometimes it feels like it's really hard to get started. I've not seen a AA battery before. So we were making a stacking game just with these, with pieces of rubbish that we found in our workshop. And from there, we started to work in 3D and 3D design. So that's the very first eagle that we made. This is the second iteration of the shark, which you will quickly work out is an incredibly dangerous thing to put in the hands of kids. That's the first eagle we had there. So these are 3D printed, by hand, by me, assembled with some custom electronics inside them. So ramping up the scale a little bit. And this, which I'll pass around, but please be careful with it. So this right here is the very first iteration of the plinth. And this is the plinth. So this is what we're building the towers on. Inside here is a Bluetooth module, a weight sensor, an NFC reader. I was going to open it up, but I've left my screwdriver. If anyone has a Phillips head screwdriver, we can take it apart here. But otherwise, it's got the wrong fitting on it. Classic. So that there, again, that was the first handmade prototype. It's 3D printed, it's CNC'd, it's got all of the electronics there were hand soldered. It's very ropey, but the reason I'm showing it is it did the job. So we made this in 4 months, and it cost us about $30,000. Not that exact thing, like the whole project. And the reason, see, that sounds, straight away it sounds like we're cresting a wave that's going to be hard to do. The reason it costs so much is because we had 5 different disciplines with software design, electronics, we had hardware, and business and stuff, and something else. And we reached a point where we couldn't do it on our own time anymore because there were too many things too many different things in motion. So we decided we needed to focus on it a little bit. So we actually applied for some funding in the UK. The UK is pretty good for arts funding, or it was until Brexit started to happen. We got a little bit of that, and that helped. So the reason I'm telling you that is because money quite often is a barrier to get things done. There are ways of finding little pockets of funding, or at least there are in the UK. I don't know if it's different here. I would encourage you just to explore different funding paths. Borrowing money is a legit way people get prototypes made. So once we had that, the reason that was so important is we knew that we wanted to go to Kickstarter. Nowadays, or when we were doing the first Kickstarter in 2015, I think it was, people were already starting to get quite savvy about the likelihood of things delivering. Even, they're even more so now. Some people have been burned. Enough bad things have happened that certainly me as a backer, I want to be as certain as I can be that I'm going to get the thing that I'm backing. And one way to do that is to go into the campaign saying, hey, it's going to cost this much to make. Here's all the reasons that we know it's going to cost that much to make. So starting with a prototype that functions means that you can bring on skills that allow you to take that functioning prototype and figure out, if it's made in a factory, it's going to cost this much. So starting with a functioning prototype, whether it's cardboard that's the same thickness as the stuff that you want to use as the designer, or plastic miniatures that are the same size and weight as they would be injection molded, getting something that's as close to the finished thing that you have in your head is going to help getting a good cost for it. So what did we do after we had the prototype and we needed to find out how much it cost? So there's 2 different routes that you can go, I think. There are companies that will work with you as a designer to have your thing realized. Panda Games is one that a lot of the designers out there use. And as far as I'm aware, I haven't used them, but the way that they will work is they have a lot of internal specialisms, and they can work with you to develop it in exchange for, I think it worked like a cut of the price when you sell it, or a fee, something like that. That's great, but also there's a wonderful term which is technology debt, which is whenever you do something and you pay someone else to do it, you get the end result, but you don't learn anything about the process, right? So an external manufacturer can help you get your thing done, but the next time that you want to make a thing, you still have the same hurdles that you did the first time because you haven't learned about that process. So from the start, we were like, okay, we're going to make it hard for ourselves. We want to do this thing so that if we do another thing, we can learn from what we were doing. So we decided that we were going to figure out how to do it in China on our own with no idea about how to do it. When people say they get things made in China, the mental image that you might have is traveling to a factory, talking to a factory owner, trying to convince them about what you're doing, going to another factory, comparing it to the last one. That doesn't happen. That shouldn't happen. Because you, me, we have no idea about how things work over there, whether it's China or it's America or it's the EU, for instance. I'm talking about China because of the amount of stuff in here. So we looked at manufacturing in the UK, in Europe, and China. It came down to price. There was no way that we could get this thing within an inch of being affordable by doing it in the EU, unfortunately. So we knew that China was going to have to be a thing we'd have to do. So the way that we did it is there are people out there they're called sourcing agents. So what their job is they may live in Hong Kong, for instance, and they have connections to factories. And it's their job to go out and find as many different factories as they can and check in on them, make sure they do good work. And then if you come in with an idea, they will pair you with the factory and they act as a kind of a conduit. So I talk to my sourcing agent in Hong Kong called Leo, and then he talks to the factory. Our factory are called Capable, which is always assuring that they are capable. And the aim of that is to try and de-risk what you're doing as much as possible. There's 101 ways that things can go wrong, especially with Kickstarter, especially doing something quite complicated. So you want to kind of try and reduce the risk wherever you can. So one way of doing it is to bring on outside specialisms. A sourcing agent, a graphic designer, a 3D designer, all the different specialisms you can get, bring them on. The way that we found ours was through recommendations, a personal recommendation from an entirely different industry. Thank you very much. Thank you.
Yeah, no problem.
When we spoke to this company, they'd never done anything like this before. But after talking to them, we thought, all right, we'll give them a chance. And they do a little body of work, which is kind of like an assessment of how they think they're going to do your project. And we liked it. It was good. And also, it was the only one that we had, so we thought, we've got to try it. It was by default, it was the best one. Yeah. So, by bringing on board the sourcing agent, and the way that works is they basically take a cut of every single thing that we sell. It's a small cut, but it's still a cut. But for us, it's less than a larger company would take, and it means that we learn a little bit more while still having a little bit of risk taken out.
Was it a straight up cut, or was there any upfront money?
It was a straight up cut. You'll find it's a good question. So some will want money up front, obviously. Some will be used to working with smaller entities and they know that you don't have any money. So they take on a bit of risk, and we take on a bit of risk. Specifically for us, the company we worked with had experience with Kickstarters. So they understand, there's no guarantee with Kickstarters. But yeah, that's a good question to have with the agent when you find them. So at this point, we were going into the Kickstarter. We had costs. We had a prototype. The prototype was the thing that was in the photographs. 99% of games on Kickstarter are photos of handmade prototypes. A lot of it is smoke and mirrors. And we knew that we could deliver it, and that was really important. By doing some prep work beforehand, we were really confident that we could make this thing. So, where am I? So, what's really important is when you've done this, when you go to Kickstarter, you generate something. I'm going to get a little technical here. It's called the bill of materials, which is a standard thing that's common across all types of manufacturing. There's a slide of ours in the deck because I wanted to share it. And the bill of materials is every component that you have.
Yeah, the Excel sheet they have now.
Yes, that's right. Yeah. So everything from the box to bits of card to packaging, you break down every single line and you put a cost against it. And then you do the same with labour, how much it's going to cost you to make it. Same with assembly and shipping. You put down everything. And then at the end, you'll have a price. And that's really important. Because that's how much it costs you to make. And from there, you can figure out how much you can sell it for. And that will define everything. And that's where a lot of Kickstarters go wrong. Yeah.
Don't forget the safety discount.
Oh yeah, I've got a section on that, don't worry. It's the most exciting bit of the section. Yeah, testing as well. All these things you have to pay for that no one ever talks about. You can't sell a thing unless it's gone through testing. You shouldn't. Some people do. It does. Oh yeah, it happens all the time. So you have this figure, and that's what weights your. If you're doing Kickstarter, that's what tells you how much you can sell it for. A lot of people don't do this, and they get in trouble because they will be selling things they can't afford, especially with shipping. Like Kickstarter backers. Has anyone not backed something on Kickstarter? Yeah, I kind of think most people. Shipping. I don't know if it's happened to you, but there's lots of times where shipping is calculated at the end and it's wrong, and there's an email that goes out saying, "Hey, we need extra money, or it's going to take us longer to do it," because they haven't calculated it at the start and baked it into the price. There's a lot of pitfalls there. So you have this bill of materials, and that's like your Bible. Everything you do goes into that, and you refer back to it, and you change it, and it means that you always know that you can do this thing. So we did a Kickstarter. That's a whole other talk in itself. I'd highly recommend them. They're very stressful, but it's like owning your own business. It's very cool if it goes well. So we raised $220,000, which was really good for a weird hybrid, not quite video game, not quite board game. And we got 2,200 backers. But because we did the bill of materials, we knew that wasn't going to be enough. At that stage, some people will say, all right, game over. Or the other thing you do is you start to look for other sources of funding. So we took some investment because we wanted to make this into a thing that could be sold in shops. So we actually went out, we put together a business case, which again is a whole other talk. But the reason I mention it is this, again, there's this idea of a Kickstarter is the only way that you can fund your thing, and that's your entire source of income. And if you don't do it, then it's the end. That's not the case. A lot of Kickstarters, especially the ones like, the big boxes of miniatures, the miniature heavy ones, they know going in that they're not going to be able to fund this thing just through their backers. So a lot of them weigh it against getting it into shops, like after sales. So yeah, for instance, okay, so tooling. Start to talk about manufacture a little bit now. Because we did our homework before, so by tooling I mean, right, let me give you some bits and bobs. Manufacture these, so I'll send these around. So these are some little halves of some of our pieces. This one there. So a tool is a big piece of aluminium or steel. For those pieces, it's probably it's a cube like this, and it's cut in half, and it's like a kind of cake mold. Anything plastic, any kind of miniature or anything comes from a tool. Anything you make that's a different colour, 9 times out of 10 it means a whole different tool. We have a lot of different colours in here. There were 7 different tools. The combined total of all of the different tools was about $60,000. That's a lot of money. So you take out $60,000 from what we raised, there's not a lot left to actually make it and do all the other things. So we knew that because we'd done our homework before.
Is $60K for how many tools?
7. Generally a tool will cost from $5,000 to $6,000, depending on where you get it made. Yeah. There's lots of things you can do to reduce that. Sorry.
It'll range on the size of the part.
Exactly. And the number of, it's going to get really interesting, the number of gates and different things. I can talk to you about that. So, oh yeah, electronics as well. This is where it gets really fun. So these here are the little circuit boards that are in each of our pieces. They're not there at this time. It's an NFC tag. It's a version of the same thing that if you have contactless payment on your bank cards, similar kind of thing.
You can get those generic ones.
Yes, there's lots of different ones you can get. We designed our own because we wanted a good read distance. So those there, they run to like 5 cents or something per one because they're being made in such huge numbers. The cost comes down. So that's another process that you have to run, but it's the same thing. You find someone who knows how to do it, and you rely on them. You bring them on board. You give them some cash, or you offer them a percentage or some kind of partnership. Because there's no way in hell that I could have done that. I'd still be doing it. So you bring people on board. So packaging, I wanted to mention as well. So packaging is really interesting. If I encourage you to, when you're out in the floor, have a look at the packaging, the games you're looking at coming. People always forget about packaging, but it's really important, especially nowadays, because we all have a responsibility to be environmentally friendly as possible. Packaging is a horrible way of causing waste plastic. So we're still not crystal clean, by the way, but ours we designed not to be throwaway. And also I didn't bring a copy of it, but the new game we've made has no disposable packaging at all. But it costs more because of that. Like little bits of plastic are the cheapest way, and the factories are going to want to do it because it means that they can guarantee that the box doesn't get destroyed in transit. So whenever you open like if you picture an action figure and it comes in a little clear clamshell and it's got the cable ties, that's not to make it look nice, it's to make sure that when it's sitting on a ship for 4 weeks and it's being rocked back and forward, that it comes out and the thing inside isn't damaged at all. So packaging, don't forget about it. Think about ways that you can make it tailor to what you want and the values that you have.
I was actually going to ask about that. When you were working with factories, was there a way for you to ask about ethical sourcing? If they section out their work to other factories in other countries that don't have as good labor standards? Is that part of it?
Yeah. I was going to talk about that. I'll do it now. So another thing that I was going to say is, hypothetically, if you got to the point where you have a partner and you've settled on a factory, I'm really surprised by the amount of designers who don't visit the factories to see what they're like. It's something that I've done a lot, and again, it's an extra cost you have to weigh up. But you can make sure that you spot mistakes, because they're never going to know the thing that you make as well as you do. And B, you can check to make sure that they're doing things in a good way. So with our factories in China, we went around, we did inspections. There's a lot of legislation that you can follow to help you figure out what you should be looking for. Where do they get their chemicals from? Where do they dispose of things? How do they treat their workers? Very, very important. China's getting a lot better.
Yeah, it is.
Yeah.
Well, and I know from the fashion industry, I've actually looked into some of that, but because they're getting better now, a lot of factories will parcel out their work to Bangladesh or other countries,
right.
And then it's second hand, and then some people don't have a way of knowing that.
I imagine it happens a lot more in fashion because of the quantities.
Right.
With our things, our sourcing agent visits every factory during a production run, takes photos, sends us reports. There's a QA process which is set by law that they have to follow, and the reports are sent to us. I guess it could be faked, but our sourcing agent is a friend of mine now because I've been working with him for so long, and I think he would do that. Another thing they do, which I heard about, was factories will sometimes club together, 4 or 5 of them, they'll club together to buy another factory that becomes the show factory. Sure. So whenever someone comes to visit, they'll take you to that one. I've never seen that. So,
Well, it's awesome that you thought about that when you were producing it.
Yeah. I'm sure Panda is really hot on that as well, but you just need to know that you have control over it. If they don't make you as the client happy, then they're going to go out of business. So a lot of times they will change the way that they work based on the thing you're making, especially with toys and games. They're genuinely nice people. So after the Kickstarter, there's a process where you go from your 3D printed models to production ready parts. And that's where, again, unless you know what you're doing, you should absolutely get some help. This bag of bits, that's a flamingo. I'll pass that round. So these were all single part, that's a dragon. So when I sent these to the engineers we were working with in the factory, they helped to take them apart and make them into bits that they could then make. Because again, I wasn't confident that I could do it on my own. I don't know the machines they use, I don't know the processes they use.
So those are the ones that you get there?
No, they've come from the injection molding machines. I send them files that are like this, solid, or broken into 2 parts. I don't bother doing all of the internal stuff because they'll redo it. Because every factory has different machines that need different tolerances and angles.
So
I wouldn't do as good a
they
job.
do this part.
They do
It's
it.
their own machine.
They do it because it's their machines, yeah.
Something,
I'm sorry?
something we do in printing, basically. You don't give them the book bound, you just give them the file with all the
Right, and they know how to do, yeah, exactly. Again, it's a way of de-risking it. I don't want to give them something and force them to make it and it comes out wrong. I'd rather work within the methods that they know about, right?
So a lot of times what they do is certain geometries, it doesn't, may work differently in a 3D printer, but it doesn't work the same.
Absolutely. This,
So
I bought some for
they
that.
have to almost re-engineer it a little
Yeah,
to
so
get it to work in the mold.
draft angles, yeah. So that thing there, impossible form. A lot of the ones that I've sent around, like this, you couldn't make this. Okay, impossible. So that's where what I didn't want to do is just give them this and say do what you want to change it and make it, because they're engineers, they're not designers. So I work quite closely with them to figure out what needs to change, and then I make the changes, and then they do the shelling and the. Sorry, shelling means to make a part thin, because they know better than me. Like, you know, I'm not going to try that. The same with these actually. I'll hand these out. So we did an expansion for Beast of Balance, which is called Battles, and we wanted to use NFC cards as a kind of the same way of interacting with the game. So these cards are made of PVC plastic, and they have an NFC card in them, but you wouldn't really know. So we worked with another factory to design these from the ground up, design the antenna, which is the thing inside it, and make them. But again, we worked with their engineers to do it. Sorry, I'm rambling. So we have, at that point, we've been through something called design for manufacture, so we have lots of parts, and that's when things start getting a bit more expensive because they have to make the tools and start to pump plastic through the machines. If you have the URL, there's some really nice video of the different processes that we went through. I captured all of it. So the parts are made through a process called injection molding. Pretty much any plastic thing that you've got on you now has probably come from the same process. They are ultrasonically welded, which is an amazing process. If you have a car key on you and you see it's got a seam around it, but you can't get it apart, it's done through ultrasonic welding, which is so they take the 2 parts, put them together, and they vibrate them super fast to the point where the plastic melts just a little bit and it joins together. It's amazing. It makes a really horrible sound.
There's no glue
There's
There's no glue.
no glue. It bonds them together.
They do this with steel too, and it costs a lot.
You do it with steel?
Yeah.
Damn.
Friction.
I guess it makes sense. The electronic tag goes inside, and then we had, so I'll pass this around. So these are the production parts, and if you look at that, so that's been welded together. You won't be able to pull them apart. Sometimes there's a little bit of flash on the outside. So you start getting things back, and they'll make some, and they'll send them over, and they'll be wrong, and you mark them, and you send them back. And eventually you get to a point where you have a thing, and it looks cool, and you're happy. and you have to say, I want to have 5,000 of them. And that's when you need to have to pay for it. So the way we work, if it's of interest, is we will pay a percentage of it up front, and then the rest of it on delivery. It's pretty standard. But at that point, you have to have the cash to pay for it. Otherwise, they won't send them out. Yeah, I don't know if anyone's. Do you have How It's Made over here, right? The TV
Yes.
show, I think.
It's the best show
Isn't
in
it?
the world.
It's just that in real life.
I have like hours of it on my DVR.
It's so good. Yeah, if you're at all interested in manufacturing, making a thing is a really good way of getting close to those techniques. So then, just to finish off the process, we started to get the plastic parts back, and the ones that I sent around, you'll see they're smooth. These ones here, we feel they've got a just like rubber texture to them. And what happened is we started to get some sets back, some test sets, and one of the things that a stacking game has to be able to do is stack, right? Otherwise, it's not very good. And the problem was they were all too slippery, which made the game impossible to play. So
They changed the texture of the mold to get this.
we couldn't change the texture of the model. We couldn't get enough texture. Actually, it's wrong. The coefficient of friction. I'll spare you that side angle. It's not about putting texture in. Because if you mount, okay, talk amongst yourselves. This is amount of friction, yeah? If this is a texture, there's less friction.
Yes.
There's actually less surface area. And because it's a light texture, you can't do that and equip in.
Okay.
It wouldn't work, we tried it. So the only way, so what we had, it was a problem is we were going to start making all these sets and it was too hard to play. So what we came up with was it's a rubber spray that's applied and baked on. If you have like a mouse at home, you know it's got like a textured surface. It's the same thing. Some laptop sleeves are made of the same stuff. So it's an extra process that's applied to the pieces, which costs us more. But you know sometimes you have to solve problems as you go, and you need to be flexible. That was an instance where I was totally at the will of our sourcing agent in the factory. I reached my capacity with being able to problem solve that, and that's when having people who know what they're doing is really handy. Excuse me. So we solved that problem. The next thing, you mentioned testing, really quickly because it's not the most glamorous of topics. So anything that you buy will have various different bits of legislation and somewhere. I was around the back, I think. Turns out you can't just make a thing and sell it to people. It has to be proven not to kill them. That's something that no one really shares. Yeah, right. Yeah. So
with the neodymium-magnet in the United States, that kid could swallow the parts and
yes.
with the magnet.
Things like that.
Yeah, there's so it ranges from hey, a child is going to lose their eye on this, or a bit's going to break off and they're going to swallow it. So choking hazards, there's a million different buckets that you need to go into to make sure your thing is right. It has to be safe for kids to play with. That has to do with the age that you're going to sell it for. So if you're making a game that is for 13 up, you have less boxes you need to tick than if you're going to sell it for 3 up, for instance. Again, there's no way that you'd know this. There's no way that I would know this. So you find someone who specialises in it, because every country has different legislation as well. So, for instance, for us, our game is 7 up. That means that if this warthog tusk breaks off, a kid cannot swallow it. Well, they can swallow it, but it's not going to kill them. And that's a scientifically proven thing, because what they do is they break it off and they see if it fits through a child's throat. No, a little thing that has a size on it, and if it goes through, you're fine. If it doesn't go through, no. If it goes through, not fine. If it doesn't go through, you're fine. It's the right way. The same things with sharp corners. Like you can't have sharp corners. They'll tell you this. Beveled edges, rounded edges, angles. So there's that side. Sorry.
If you decide to sell in one country first, can you then go to another country and get it revised, or do you have to do like all
Yeah.
of it at once?
So there are certain countries where the standards are higher, so if you do those countries first, the other ones tend to fall under. The US is pretty good. Germany is really good. Very, very good. So, yeah, typically you'd say, okay, we're going to test for USA, and that means that it covers all these other countries. So there's stress testing where they will sit and there's a machine that will pull these hundreds of thousands of times until it eventually breaks, and that's why this is a two-part piece, because if it breaks at a line, that's not good. There's things like chemicals. So whenever you make something in a factory, there is a department there should be a department that's entirely separate, where they will test all the pieces to make sure that there's no harmful chemicals in them. And you get those reports, or your specialist gets those reports. And then I mentioned before there's transportation tests, which is a whole separate thing. Your box will be put on a vibration platform that will vibrate for hours to simulate the sea voyage. And if things come out and they're scuffed or messed up, then they'll tell you. And if it's acceptable to you, then it's fine. If not, then they go back and change things. Costs money. Obviously, it costs money. Some of it you can skip. The transport testing you probably could. Some of it you absolutely can't. So again, this is an instance where de-risking is really important. Find someone who can find the right legislation and then apply it for you. A Panda Games, for instance, will know all of this and will should make sure that your product, your game is good and that it has the right logos on it in the right place. Oh my God, there's so many. You have to have the country of origin in this particular corner, this far up and this far in, and it has to be that big. Everything has this level of detail to it. Grand. So you've been through that. So you go through production, which is amazing. You get your games at the end. Hey.
As you're going along, were people telling you that you need to do these things? Was there ever a chance that you could have missed it and then you made 50,000 and then they didn't have it?
So what we did with the first game, this one here, we found a guy in the UK who used to do safety for Hornby, the model rail company, if anyone knows them. And he swore blind that he knew exactly the right things for us to do. So we paid him some money, and he gave us a report, and it was entirely wrong. He knew what he had to do about 20 years ago, and things changed. So when we we designed around that, and then when we got to our sourcing agent in China, they went, no, that's wrong. Here's all the things that you need to work with, because our sourcing agent has a toy safety officer that they work with. So our agent only does toys and electronic gadgets. So he knows the standards that need to be...
Makes them for other countries.
Exactly. So to answer your question, we got it wrong, and then we found out just in the right time, because the step after that is it goes to external testing, which is a whole other process where they put it in a big chamber and they check that it's not going to mess with radio frequencies for emergency services or satellites going overhead. I'm not joking. Military frequencies is some of the things that they test for. And if it does, you have to go back and you have to change it.
Or
But
send it to a different market.
no, don't do that. Do not do that, no. So it's really important to find out before, because the further down the process you go, the harder it is to make those changes. So we did our production run. We made, I think, about 5,000 copies of the game, very exciting. And then at the end of that, whilst you're still in the factory, there's a QA process, so an external person comes in. It's fascinating, it's like a science. So there's boxes and boxes and boxes, and they'll have a table that says, okay, go 3 columns along, 5 boxes down, take that one, and then go 5 columns along, 3 boxes up, and take that one. So they take specific ones, and then they take them all apart, and they examine every single piece, and they write the defects, and they play the game. That was really fun, seeing like a whole room of really serious Chinese engineers trying to play a stacking game. At the same time as they were making, in the next room, Frozen dolls, singing Frozen dolls in multiple languages and testing all of those. You do not know hell until you've listened to that. song, that song, in like 5 languages through tiny speakers for 24 hours. So they test it all and they come out with a report and you sign it off. Are you happy with it? And if not, they go back and they make the changes. Not very happy, but they do it. And then it's amazing, you have this moment where you have a big palette of things all ready to go. And then a whole other process kicks into, which I'm going to stop now, but you then have to get them on a ship, and you have to make sure that ship gets to the right place. And then you have to get it from the ship into a lorry, and then you have to get that through customs, and then you have to get that to a distribution centre, and then that gets broken up, and then you have to ship it out to your Kickstarter backers. De-risking it, again, is a big thing to do. There's Shipwire. Yeah, Shipwire is a system that was set up, a company that was set up to help Kickstarter backers do that whole process. So when it works, you don't have to worry about it too much. Hey.
How long was it from your Kickstarter closing to shipping it?
It was like a year, I think. A little bit
That
more.
seems fast.
But you had done a lot of work ahead of time.
We had, yeah. So we knew what we needed to do to get it done. The game that we've just made, which is a lot more simple than this, it's a more traditional kind of plastic pieces and cardboard, was 6 months start to finish.
You learned your lesson.
Yeah, make things simple and cheap. No, you know what? That there's a whole other load of problems that came up. So I don't think you can ever know everything. It can take a lot longer, but the better the quality of people you have on your side, the more control you have over it. So then you have a wonderful moment where people get their stuff and it's very happy. That's happening this week with our expansion stuff, so I'm very excited about that. And then the last, if you look on the slide, I wanted to share, it's a document that I made. If you are thinking of doing your own project, it's a schedule it's a schedule that I use. It's called a Gantt chart. So you have a task here, and then you have a task here, and you know that this one's going to take this long, and then this one can't get done until that one's done. So you have it like that, and then you have another one, another one, another one. It's a really great way of planning out the whole process. I've shared my spreadsheet that I work to. When you're welcome to use it, make a copy. Please don't save over it. Someone else does. Because it shows all the different points that you need to go through to make something with plastic or electronics or packaging. So hopefully that'll be useful to someone out there. I think that's it. Sorry, it's a bit rambling, but yeah, it's not as hard as it might seem. Just de-risk it as much as you can and find friends who know things you don't to help you along the way. That's it. Thank you.